So basically, we have started with our packed arrays, and we have also discussed about unpacked arrays. And in unpacked arrays, we have seen 1D, 2D, and 3D, and we have also started with dynamic arrays, and we have also seen how to create a 1D dynamic array, 2D dynamic array, and we have also seen how your queues are going to look like. Yeah. Now, when we were discussing about dynamic arrays, we have seen everything, and why we were using queues. Any idea? Why we came to queues instead of dynamic arrays? Exactly. So basically, in the case of your dynamic arrays, you need to every time create a memory, right? So using the new keyword, you need to create the memory every time. So that's why we came to queue. Whereas in the case of your queue, you don't need to explicitly create the memory. Whenever you insert the elements into the queue, automatically your memory get allocated for that, right? So that's why we are using that particular queue. And if you want to insert any element into the queue, what is the method you are going to use? Can anyone tell me? If you want to insert any element into the queue, what are the methods which we can use? Yes, we can use push underscore front, push underscore back, or insert. We can use, right? So we can use insert, push underscore front, push underscore back. We can use and okay. And if we want to remove an element from the queue, we are going to use pop method. Okay. What is this? Devaranganath transcribing this call with. Okay. So basically, if I want to remove this particular, yeah, I can use pop. Okay. So if I'm going to use pop, if I'm going to use delete, I cannot basically get the element out of the queue. It will delete. I cannot collect it. Okay. So using the pop only, I can collect it. Right. Now, so let us see this how we are going to use this another type of arrays which we are going to have. Okay. Now, so let's say if you are going to have a dynamic array, let me show you. So in the case of your dynamic array, let's say if I am going to create a dynamic array int dyn, and if I'm going to write down dyn is equal to new of 10, then total 10 memory locations will be created like this. 1, 2, so on to 10. Okay. So like this, I am going to have 10 memory locations. And let's say if I am going to store only the elements in the 0th location and first location and at the last location. Now, so the locations which are present in between are wasted. If I'm not storing any element in middle locations, then all these particular memory locations are wasted. Am I right or wrong? Yes or no? You have created total 10 number of locations, but if you're not utilizing this middle locations and you're only storing the data in this up and down locations, then obviously your middle locations are wasted. Okay. Now, how can we overcome this particular issue? So you might say that we can use a queue. Okay. But if you are going to use a queue, you are supposed to store the elements in sequential memory locations only. You cannot have random locations. You cannot have data to be stored in different locations. Only you can have the data to be stored in sequential locations in the case of my queues. Am I right or wrong? Yes or no? I cannot have because every element is contiguous. Every location is contiguous in the case of queues. Okay. Now, so to overcome this particular issues which I was facing in my dynamic arrays and queues, I'm going to use something known as associative arrays. Okay. Now, what is special about this associative arrays is there are many special things about this associative arrays that we are going to see in this particular lecture. Okay. Now, first of all, let us see the syntax. So the syntax is again the same thing: data type followed by the array name followed by star symbol. Okay. So in the case of your associative arrays, you are going to have this star symbol, and in the case of your queue, you are going to have dollar symbol, And in the case of your dynamic arrays, you are going to have empty brackets. Okay. Now, so let's say if I'm going to have an associative array int assoc underscore array, I have declared a associative array. Now, let's say I don't need to explicitly create a memory using new operator like I was creating in my dynamic arrays. In your associative arrays also, you can dynamically create your memory locations in your initial begin block. So how to create it? You're going to simply write down initial begin assoc underscore array of 1 is equal to 2. Okay. You cannot simply write assoc underscore array is equal to 2. No, it's an array. Okay. So you need to definitely mention the index. Okay. So you're going to mention the index. Okay. And let's say assoc underscore array of 10 is equal to 3. Now, can anyone tell me how many locations are created over here? It's a simple question. If I have written assoc underscore array of 1 is equal to 2 and assoc underscore array of 10 is equal to 3, can anyone tell me how many locations have been created over here? You might see the index as 10 and you might tell 10 indexes, 10 locations are created. But the specialty of this associative array is there are only two locations which have been created. That is the location number 1 and the location number 10. And no other locations have been created. These are not at all created. This is a specialty of your associative array. Whereas in the case of your dynamic array, you need to explicitly create the memory locations, and if you are not utilizing them, that's your fault. And these memory locations are being wasted. Only if you are storing the elements at the first, second, and last locations, that's it. No other locations are being used. It's a wastage of memory. But here, in the case of your associative array, if you are creating if you are going to insert the element at first location, okay, that particular location will be created. If you are creating the memory at the 10th location, if you are inserting the data at the 10th location, okay, only the data, only that particular location will be created. Is it clear for everyone how the associated array is working? Is it clear? So in the case of your associative array, continuous memory locations will not be present. Okay, that you need to be careful over here. And next, the specialty of this associative array is you can have, okay, so before that, let's say if I'm going to declare a array into dyn of 10. Now, can anyone tell me whether it is unpacked array, packed array, dynamic array, queue, or it's an associative array? If I've written int dyn of 10, can anyone tell me whether it is int dyn 10, whether it is unpacked array, packed array, dynamic array, queue? It's an unpacked array, right? Okay, it's an unpacked array. Now, what is the data type of the index? What is the data type of index? Data type of index. Can anyone tell me what is the data type of index? Int. Exactly. So it is basically int. So you are going to write down dyn of 0, dyn of 1, dyn of 2 like this. You are going to have it, right? And it's a int data type. Exactly. Okay. Now, in the case of your associative array, you can have index of any data type. For example, you can have dyn. Okay, let me declare an associative array int dyn of star. Okay, so I can simply write dyn of 0 is equal to 1. Then a memory location will be created whose index is equal to 0 and the element 1 is stored. Okay, well and good. And if I am going to write dyn second is equal to 2, then a memory location will be created and whose index will be named as second. This is a special feature which is not present in your dynamic arrays and normal fixed arrays. Okay. Let's say if I'm going to write down dyn third like this, then a memory locations will be created whose index is third, and the element will be stored in this particular array. Okay. Not only int and string, you can have any data type which is present as an index. Okay. That is the specialty of this associative array. Okay. Is it clear for everyone? So in your case of your associative arrays, you're going to have non-contiguous memory locations, and you can have indexes with any data type. Okay. Yes. Now here the catch over here is, let's say suppose if I'm going to write down int dyn int. Now can anyone tell me what type of array it is? It is an associative array. This is also an associative array. Not only if you see the star, if you have any data type which is being declared with in the index, it is a associative array. Basically, the star describes that you can have any index. Here, the star describes that you can have any index. And but if you specifically mention that my index should be int, then in this associative array, the index will be of int type only. Okay, so this is nothing but my index. Let's say if I specifically mention that my index should be of type integer only, then the index will be of type integer only. Let's say suppose if I'm specifically mentioning that my index should be string only, then it will be of type string only. Okay, so you have the facility to you have the flexibility to mention the data type of your index. Let's say suppose if you are going to write down star, then you're going to include all the data types as your index. You can have any data type as your index. You can mix the data types. Okay, so this particular thing you need to be careful. No. Not the default data type is not int. Okay. So basically, if you have declared like this, you can have any data type. Okay. But if you are specifically mentioning it like this, it is of int. Okay. There is nothing like default data type. Yes. Once try it, Raghu, whether it will come or not. In second memory, can we store string or only int? In second, you can have int. Data type of your element is int. Data type of your index is integer. Okay. So if I mention int divine string, then what does that int do? Okay. I will come to your question side then. Okay, Pranav. So what is your question is int divine of 1 I have created and some value, int divine of 10 some value, and int divine of 2 some value. Then an array will be created with the location with the index 1, with the index 10, and with the index 2. Like this it is going to create, and no other memory location is created. Okay. Yes. And coming to Saicharan, here int basically specifies what is the element data type which you can store over here. This data type on the right hand side you have right element data type that it specifies. Is it clear? Shall we move forward? Yes. So let us see some examples. If index is of string, the data type should be string or any other data type. It can be of any other data type. Let us see one example. It will be clear. Okay. So let me create a module, and here I'm going to declare a associative array. Let's say it is of string data type. The index is of string data type. Okay. Now what I'm going to do within an initial beginning block, assoc underscore array of first is equal to 1. Okay. And I'm going to display it. Dollar display The value of is percentage p, comma, assoc underscore array, and followed by end module. Let me display it. See. So we have a memory location with index as first, and the value that we are storing over here is 1.